right, we're going to talk about Newton's method. And what Newton's method is it's a procedure to estimate the zero of a function. So Newton's method, the first thing is you're going to guess a first approximation of the solution, okay? So you're trying to make an educated guess. It doesn't have to be really close, but the closer it is, the less iterations you'll have to do. A lot of times a graph may be helpful in getting that first guess. The first approximation is used to get a second, the second to get a third, and so on, using this formula of x of n. So the new guess is going to be x of n minus f of x of n over f prime of x of n. Okay? So a lot of times with this, what I will do in Newton's method is I will set up a table. So it says find the positive root of f of x equals x squared minus 2. Okay? So I need f of x and I need f prime of x. Well, that's just going to be 2x. Okay? Now, what I'm going to do, and a lot of times you're going to want to get within so close. So it might be we want y to be less than or equal to 0.001. So something like that. So we want it to be within, this kind of bound. We want it to be fairly close, maybe within 5 decimal points or something like that. This one we could actually solve. We know this is going to be the square root of 2, but we're going to kind of look at that. All right. So now if I find f of x, I have 1 squared minus 2, which is negative 1. If I find f prime of 1, that's 2. And so now I have this function. I have 1 minus negative 1 over 2. So this becomes negative, which is a positive. So this is 1.5. Now this 1.5 becomes my new x, 1.5. So now I take 1.5, and this is where you're going to need a calculator. 1.5 squared minus 2 is 0.25. Now I'm going to find 1.5 here. So this is 3. Now this is not close enough to 0. It's 0.25 off. So now I'm going to run this. So I'm going to go 0.15. So 1.5 minus 0.25 divided by 3. And then this is going to give me 1.417. Okay, now I'm going to take this value, 1.417, and it becomes my new x. So I'm going to go 1.417 squared minus 2. This is going to give me 0.00789. Not quite close enough. I go f prime. Now I'm going to plug this in here. So I'm going to go 1.417 times 2. This is 2.834. Now I'm going to find my next guess. So 1.417 minus 0.007889 divided by 2.834. And this is 1.41422. Goes on forever and ever. So I'm going to kind of rewrite this. Okay. I'm now going to plug that in 1.41422 squared minus 2 is 0.00002. That's within our bounds, so that would be my approximation. Okay, this is really close to actually the square root of 2. Okay, and we can keep doing that and get closer and closer and closer and closer. Okay. We're going to do this again, but now instead of saying, hey, where is the positive root, what we're going to do is we're going to find the x-coordinate of the point where the curve y equals x cubed minus x crosses the horizontal line of y equals 1. So essentially what we're doing is we're saying x cubed minus x equals 1. Okay, we're trying to find that value of x. Well, we don't really like doing that. We like to find it to 0. So what I'm going to do is I'm going to move my 1 over. Okay, so this essentially now f of x is going to be x cubed minus x minus 1. f prime of x is going to be 3x squared minus 1. Okay? And so now I have to kind of come up with these. I'm going to write these over here. All right, f prime, 3x squared minus 1. Okay? So now I'm going to plug in 1. Okay? I'm going to plug in 1 here. I get 1 minus 1 is negative 1. I'm going to plug it into f prime. 3 times 1 squared is 3 minus 1 is 2. Now, this is not close enough to 0. Okay, remember, we're trying to find 0 because we shifted this over. Okay, that's not close enough to 0, so now I need to find that. So now I go 1 minus, so this becomes 1 minus negative 1 over 2, which is 1.5. My next iteration is I'm going to plug in 1.5. So I'm going to go 1.5 cubed minus 1.5 minus 1, and this gives me 0.875. Still not close enough. I need to keep working, so I now need to plug it into the prime. So 1.5 squared times 3 minus 1 is 5.75. So this becomes 1.5 minus 0.875 over 5.75. And I need to now come up with my new piece. 1.5 minus 0.875 divided by 5.75. And this now gives me 1.348. Well, we'll go 78. We'll go out to 4 decimals. Okay, so my next one, my third guess here. So I started with my initial guess, my first iteration. Now we're on my second iteration. I'm going to have 1.3478. Okay, I'm going to plug that in. 1.3478 cubed minus 1.3478 minus 1. This gives me 0.10057. Okay, not quite close enough. I'm still 10th percent off. So I'm going to have to find the next iteration. 1.3478 squared times 3 minus 1 is, this is 4.4497. So now I have 1.3478 minus 0.10057 over 4.4497. All right? It's kind of a lot of work and a lot of calculator work. 0057. And so my next iteration is going to be 1.3252. So third iteration, 1.3252. Plug that in, so 1.3252 cubed minus 1.3252 minus 1 gives me 0.002057. Okay. We're going to stop there. We could do another iteration. We could keep doing iterations until we get within our bound. It's the same process over and over again. So Newton's method is used to approximate a graph at those pieces. Either we're going to have to solve for it to be where it's 0. So if it says, hey, set it equal to 10, we're going to bring that 10 over so it's equal to 0. All right. So that's Newton's method. You're going to need a calculator to work these out.